Anchor rod's too short. That happens. Many of you, and I probably did it before I knew better as well, might have had a solution where you say, oh, well, weld the nut to the anchor rod. Go down in there and make a little puddle weld. Well, you cannot get a good weld. You cannot get AWS qualified weld doing that. And if these anchor rods have tension on them, you should be concerned. It is okay to weld the rod to the base plate, but don't try to weld the rod to the nut. So that happens frequently. What can you do? If they're too short, extend by welding on a threaded rod. Use a coupling nut. Cut it off. Use epoxy anchors. Weld the base plate to the rods. That's a solution I mentioned. And, for example, perform an analysis for the nut using the number of threads engaged. Larry and I have talked. We think maybe we should do some tests someday. I can't find this in the literature, but I've been told many, many times, and I've used it, is, you know, if you put a nut and it's fully threaded on the anchor rod and you put it in a testing machine, the rod will break. Now, if you don't have all the threads engaged, the threads are going to strip. But it's pretty linear. In other words, if you have half the threads engaged on the nut and you would put it in the testing machine, you would get about half the strength of the bolt. So think about that. You can do sort of a calculation, and if it's not a real critical case, say, fine, it's just fine, leave it. Make sure you design your anchor rods with plenty of length, ample thread length in particular, and again, do not use high-strength rods unless you absolutely have to, because you may have to weld to them if a fix is required. Here's a couple of pictures that Larry actually came up with, and we sent them also to Dwayne Miller, who's one of the speakers, I think, in the last day here on welding. Dwayne is, I call him the new Omar Blodgett. Dwayne's an excellent speaker, and if you have an opportunity, I suggest you go to that seminar. He's very knowledgeable about welding. But here was the solution. Here's the top of the footing or pier. Cut the rod off. This is just becomes a runoff tab. It's a plate that's fabricated and 1/16 inch bigger than the rod. You slip it over there, tack it in position or hold it in position. Bevel the threaded rod you're extending, and you can make a legitimate weld that way. Another way is to, you might have to chip out the concrete, use some flare bevel welds with some side plates to develop and add a threaded rod. Now, of course, all these solutions, even this final one, is a coupling nut threaded on here, and it just extends the anchor rod. This is nice. It doesn't involve welding. But all of those solutions, of course, are going to mean that you're going to have to torch out the base plate to accommodate the extra material, and hopefully your anchor rods are far enough from the web or the flange that allows you to do that. Okay? But otherwise, you just use some other solution. But these are nice solutions if you can do it. Anchor rod's too short. That happens. Here's a picture. Here's maybe a better picture. A coupling nut was going to be used, so the base plate was cut out, and now there was room for that coupling nut, and of course there's going to be a giant washer on the top. Anchor rod's too long. That happens. It was an old project. I think we were evaluating this structure. And what was the problem here, but they used the pipe sleeve to, it wasn't enough thread. The thing that I think of first, and I've encountered this a couple of times, if the anchor rod's too long, guess what? The likelihood is that it wasn't put down in the concrete far enough. It probably wasn't fabricated too long. So do some checking on that. Get the shop drawing, see how long an anchor rod is supposed to be. And if you need the embedment length, then something has to be fixed. My mind just wandered again. I don't always mention this, but I hope most of you are no longer using bent anchor rods, but you are using an anchor rod that has a nut on the end that gets buried. There is a significant strength increase for overturning and uplift with the buried nut concept. The bent anchor rod will straighten out in that concrete and pull right out of the hole. So it's a little bit more money, but I encourage you to use the threaded nut. They may have to be tack welded so that when you tighten the top nut it doesn't spin in the hole, but I encourage you to do that. You might have to provide a lot of washers if they're too long. You might have to weld the rod to the base plate. You may have to thread it in place. Those can all be done. Use plenty of extra threads on your anchor rods. And as I mentioned, check for proper embed distance. We had one project a number of years ago. It collapsed during erection where the anchor rods were fabricated too long, and they were actually bent rods. And they were put in, the bend, the hook, was located about 4 inches below the bottom of the footing in the dirt. So when the erector put the steel up and got a little wind, it slammed that up out of the dirt, and the 4-inch movement was enough. Hey, we'll get the engineering like P delta happened. Okay, that it tipped over. Okay. You're going to be amazed in this seminar. There's only 2 equations in the whole seminar. That's because Larry and I can't calculate anymore. But no, relax today, because this will be the only one where you don't have to get out your calculator, okay? Anchor rods bent. Sort of a rule of thumb that generally works is that if you have a 36 KSI anchor rod, and it's not bent more than 45 degrees, you can bend it back straight. I think we have found one instance where a crack occurred when this was happened, but I don't know if that anchor rod was ever checked to see if it was truly 1554 material, or whether somebody went to Menards and got an anchor rod. So you can bend them back and straight. And in our snow areas, like we are in Chicago and thank you for not calling me a cheesehead when I walked up here. It snows in the winter. The anchor rods are in place, and the contractor has to get the snow off the site, so they bring in the bulldozer and he runs over all the anchor rods. That happens frequently. That's how this picture was taken. So you can cold bend. You can heat the rod if you want, straighten it out. If it's a high strength rod, you cannot bend it. You're going to crack it, and you can't weld to it, so then you have to replace. Prevention: don't use high strength rods, and provide protection for those rods during construction. That's not your job or my job, but that's the contractor's job. If anchor rods are broken, which happens, evaluate the need again. Again, think about using epoxy anchors, and again, provide protection so that you try to eliminate them from being broken. I mentioned the 90-degree pattern. If that is the problem, all these solutions that we've talked about, you have to think about project by project and which is best for the given project. I will say the little fixes there where we had the extending the anchor rod, you might draw those up and put those as standard details, put them in AutoCAD, and that way you can send them out to the field easily. You don't have to resketch them every time. I was amazed. I'm doing some work right now, and I'll mention it this afternoon, writing a technical they call them technical digests for SJI, on how to reinforce steel joists. Because it's something you and I come up against, and there's the right way and the wrong way. There's a lot of wrong ways. And so I collected from all the joist manufacturers details that they have for reinforcing. It's amazing. They all had beautiful standard details for reinforcing joists because it happens so frequently. And they just send these out to the job site. Of course, they tell you as soon as they do that the joists no longer belong to them. You know, you now own the joist, right? So, but they were very nice details. I don't know if you've ever had this, but the column base plate punches through leveling nuts. There's no, as you know, one way to set base plates. And each erector has his or her favorite way, and it's hard to fight them, so you let them do what they want. But it has happened. Leveling nuts, if you're going to use a leveling nut, you know, and they bring these up to elevation, shoot them, and maybe tack them in place so no irate worker can come around and lower them, you know, which has happened. Or somebody needs the nuts and they come and take them off. Tack them in place, get the right level, set the base plate. Now, with the hole sizes that we recommend in AISC, if you're going to use leveling nuts, make sure you use a big mother plate washer on top of those. Because if you use a regular washer and you get very much weight on that structure, it can punch right through. I had it happen to me one time. So use thick washers when using leveling nuts. Specify proper grouting time. That is, you cannot pour the floor above this until, you know, you've grouted the columns, kind of concept. You can calculate that. And we find that it's better to use shim stock instead of leveling nuts when you have fairly large loads. And some erectors, oh yeah, well, they kick the shims out of the way. True, there's no best way, but we kind of like shim stock on heavier columns. Okay, we'll get away from the footings and anchor rods. I guess the second thought I had in writing this is what happens frequently is problems with spandrels, facades on buildings. And the good part of that is more design related, I believe, than it is fabricated or erection related. Depending on the kind of structures you do, I think the best curtain wall system is one that's foundation supported. You know, it ain't going nowhere, as we say. You just rest it on the foundation, set it up, and you tie it back. The next best, of course, is supporting the curtain wall off the columns, because the columns don't move that much. And the worst is if you have some sort of system that has to be supported off a spandrel beam, because that beam is going to deflect, it's going to twist, it's going to rotate, and it makes the erector very nervous. You need to be somewhat of an ironmonger when you design spandrels. Make them big enough so they don't deflect and twist. And we have a group in our office of 5 engineers. I've got 40 structural engineers in the office. We have 5 of them that do nothing but precast curtain wall work. And they tell me if I have to walk across the hall, because I won't let them sit on the same side as the good steel guys. They're across the hall. They tell me that when they are working for one of their precast curtain wall suppliers, if they see a steel project, they bid it higher than if they see a concrete project. And it brings tears to my eyes. You know, I say, well, why do you do that? Because you guys don't design the spandrels stiff enough. And we know they're going to deflect and there's going to be erection problems. So then we try to reassure them that I don't know if they'll ever change. There's three principal areas of concern on spandrels: projection, deflections, and tolerances. Okay, those are the three things that come up day after day. Spandrel too far out or too far in, you may have to redesign some connections. Particularly if it's too far out, you can redesign or too far in, you can redesign the connection. If your spandrel beam has sweep, you may be able to heat straighten it, or you might be able to jack it into position. Okay? And you might have to provide braces to pull or push the spandrel into its proper position. Okay? To prevent these things from happening, provide adjustable connections. The erector should check plumbness of the structure as it's going up, and provide adequate bracing for spandrels and make those beams really stiff. Okay. Here's this details in the AISC steel manual. It's not recommended, because you see there is no room for adjustment. Here's the slab edge plate. Here's some sort of stud, and there's no adjustment whatsoever. It would be much better to have a clip angle on here, leaving some clearance for adjustment, and you can do whatever you want there, but a minimum of 1 inch. Okay, so that if this isn't put in the right spot, even within tolerance, you might have a chance to adjust it. Here's the same thing. We're having to tie the system to the top, to the slab, and to the underside of the spandrel beam. And this probably has some kickers up to keep it from rotating. But there again, no adjustment. Here's a bolted situation, some vertical slots, horizontal slots. Tighten the bolts up, weld it, and you're ready to go. Okay? Again, there's adjustment, and that's what's key. I've seen this once or twice. It should never be used. We want to weld this plate on, and I think we engineers are afraid there's going to be some sort of uplift here, and we want some weld under there. Don't do that. That weld is not impossible to make, but it's very dangerous to make. The erector would have to lean out over the beam, do an overhead weld. It's dangerous. Or you would have to put scaffolding up to do it. So it's better to have a weld here, and if you're worried about some movement this way, put some holes in there and do a puddle weld so that you have all downhand welding. If the facade moves or twists during erection, provide proper bracing. It's probably because it wasn't braced right, and resume erection. I refer you to this is the first place I refer you to the AISC design guides. I think most of you now know, well, maybe you don't. It's always amazing how many don't, but if you're an associate member of AISC, which costs almost nothing today, you can go to the AISC website. You can download for free any of the design guides that are out there. Okay? I might put a plug in. The new one that Larry and I just finished is available, and that's on design of base plates and anchor rods. So you can go to the website and get these. This was design guide number 3, and I'm only advertising it because my partner Mike West and I wrote it. No, we don't get any money, so it doesn't matter. Isn't that true? Nothing matters unless you get some money for it, right? No, it's not true. I wouldn't be giving this lecture if that's what I wanted to do. But Design Guide 3 deals with all the serviceability issues we could think about for buildings. And it says low-rise buildings on this slide. That's because the slide's 2 years old. And we engaged Larry Griffiths to help us with a revised one, and it covers some multi-story buildings as well. This one handle up to 5 stories. And it has things in it like this slide. It says, hey, here's some serviceability criteria for spandrels. depending on the weight of the spandrel and the situation, how much you should allow that spandrel to deflect. And you can see their numbers like span over 480, span over 600. And you all know about the brick stuff, you know, and how a brick will crack if you let the spandrel go too much. So, but this is the kind of thing that's in that design guide. Don't forget that you can have tolerance accumulation problems. You as the engineer of record may be using the proper AISC tolerances, but the curtain wall people may have different tolerances. Okay? You may have to look at how the concrete tolerances, the steel tolerances, and the curtain wall tolerances all fit together. And you may have to do something more stringent than you would normally do. So think about how these tolerances can add up. And then, of course, provide adequate adjustment. That's very important. Now a bunch of miscellaneous topics. And these were just we could have put these anywhere in the lecture series, but they kind of fit here. Everything we could think of that was sort of special. Well, I just remembered another story that I have to tell you. It's just keep you all awake. That's why I'll probably tell more stories after lunch. No drinking at lunch, by the way. Okay. We're talking about anchor rod placement. And we had a project a number of years ago that had what I consider the mother of all anchor rods on it. This was in a steel mill, and it was for the mill stands. And each mill stand had 12 anchor rods. They're a long ways apart, but they're 12 anchor rods. Each anchor rod was 8 inches in diameter. Each anchor rod was buried 12 feet deep in concrete. Had nuts on those babies, you know, nuts, real nuts. You straighten those, you get trouble. So anyway, the material, the mill stand came from Germany, and all the dimensions were in metric. The American contractor wanted his drawings in feet and inches. And we said, yes, we would do that. We should have said no. We should have said, buy yourself a metric tape, idiot. But we didn't. We said, okay, we'll do feet and inches. Well, our draftsperson had a little boo-boo. 1 millimeter became 1 inch somewhere along the line. And wouldn't you know, the only place it happened were on these 8-inch diameter anchor rods that were buried 12 feet deep in concrete. So I get a call, and I can't use the words because we're being taped, but what the contractor said, or the owner said to me. Something to effect, oh, Jim, you put the anchor rods in the wrong spot. He said, my mill stand doesn't fit. I think you messed up. And I'm sending the mill stand back to Germany, having it rebored, and I'll be sending you the bill. So we hurriedly checked, and yes, we had screwed up. So I called him back, and his name was Vince. We got anybody named Vince here? Okay. Anybody named Schiavone? His last name was Schiavone. Now, one thing I've learned in my 40 years of experience of being on a job site is you don't mess with anybody named Vince, especially if his last name is Schiavone, because you'll be thrown off the roof or something. They send, what you do in Chicago. You send people to Milwaukee, you break our hips, you do things like that. So anyway, Vince said he was going to do that. I said, Vince, you do whatever you have to do. We screwed up. Well, he actually was able to take the feet off this thing, send them to Gary, Indiana, reboard them, put them back on. The bill was $7,500, which he never sent. He said, we'll work it out. And the reason we worked it out is because we designed the steel mill so fast that we weren't checking our work. They knew we weren't checking our work. That was an agreed thing. So there were going to be a few mistakes. But the 8-inch rods, why those? I don't know. Threaded studs. Don't forget, if you use threaded studs, there's this weld flash that happens, and if you have some sort of plate or something that has to sit over that, you need bigger holes in it than normal, okay? So you can avoid a back charge. When you use the threaded studs, when the bolt access is limited, some places where holes can't be made, you know, like an HSS section, for example, where the connections might have to be laid out in the field, you might use them. You can obtain a reduced base stud that when it's put in place, the weld flash does not exceed the diameter of the base stud. And then you're better off with the holes. But I recommend that you either provide shims or make sure that the holes that are going over this are at least 3/16 inch bigger to allow for the weld clearance. Now, this is a minor thing, you know, but it might save you a few bucks someday. I look at lectures like this one. If you can go home and you learn one thing, it may benefit you. So if you pick up just one thing today, even if it's a good joke for me, that'll be fine. Banging bolts. How many of you have heard of banging bolts? Raise your hand. So a lot of you have not heard about banging bolts. Ooh, I touched this. Ooh, I touched it again. A banging bolt is a bolt in a connection that was tightened, and it slips in the bearing at some point in time, usually after the building is loaded, because that's when it wants to slip. And when a bolt slips into bearing, it sounds like a gunshot. I mean, it is deafening, scary. There's been a number of these. Unfortunately, the very first one that occurred in the United States was in a new prison. Think of it. So there's a bang, you know, and oh God, I'm glad I wasn't there. Not in prison, but not there. So they happen. We had it happen to us on a hospital that we designed, and it happened during the ribbon cutting ceremony. Our engineer that was there just sort of shrunk into the crowd and left quickly. It's usually not dangerous. It's just a bolt slipping, but you know, you have to inspect after that. But you assure the owner, you tell them, hey, that's a banging bolt, that's all it was, it slipped. You might inspect the connections. How do you prevent that? Use snug tight, so they probably slip right away during erection. I think you use single angles rather than shear tabs. You know, we spend tons of money on research on shear tabs. Many fabricators prefer single angles to shear tabs. All of the known banging bolts that I've ever heard about are in connections with shear tabs. There's not enough flexibility, so the way that it happens, the bolt slips. Whereas a single angle that's welded to a spandrel or a girder or a column has that deformation. It pulls away from the column, and that's how it handles it. So use snug tight bolts and think about using single angles. Yeah, talk to your fabricator friend, though. He may have a preference. It comes up all the time about how to resolve a dispute on bolt tension. I just simply say here, a reminder, you go to the RCSC, there's 3 pages on arbitration on what to do if there's a question about bolt tension. The best way to avoid this is not to require the bolts to be fully torqued, but it can come up. How do you resolve it? Use snug tight bolts wherever possible. And remember, snug tie is simply defined as all plies in firm contact. And it's permitted, you know, you can tighten the bolts, but just not have them inspected if you don't need the full tension. So think about that. Question comes up with contractors, are anchors on pour stops a tripping hazard? And the OSHA requirement is if the anchors project out over the beam, they are considered a tripping hazard and they can't be there, or the iron workers are not going to put up the steel. My mind again was wandering a bit because yesterday I was driving from northern Wisconsin down to Milwaukee, and I saw some giant, precast concrete girders, bridge girders going by. And they have all the little rebars sticking up and stuff, and that's allowed. But I guess it's different. What, Larry? It's a different union that erects that, or? They have to put walkways on top. Okay, thank you. So I couldn't figure out how they did away with it, but they do. So we could, I guess that means that we could put walkways on top of our beams if we wanted to. Okay. I get all my good answers from my friend Larry Kloiber, so save all your questions for him.